Lab 7. The objective is to start at the end of a corridor, randomly oriented, find the path to the corridor, and then find out that you have escaped. This is my build of it. I scanned each side of the box to see that it is confined, go down the corridor, and then find out that it has escaped. Okay. First thing is it will scan all 4 directions. Then it will drive down the corridor, scan once more, discover that it has escaped, and then turn on the green light, stopping approximately 7 centimeters away from the target. Now, that is wrong. With the corridor being about 90 centimeters. Let's try 70 centimeters and in a different orientation, such as this. So now, once again, it will scan all 4 directions. After doing so, it will turn in the direction of the corridor and drive down the corridor. Then once again, it will scan, see that it has escaped, and then turn on the green light. As such. So code. The loop is simply wait for button, 2-second delay, and then call the escape function. The escape function is here, and it is simply scan, escaped, and drive. It will do that until escaped is set to true. The scan part, 4 times, it will set temp dist to the scanned distance. If temp dist is 0, I'll explain that later, or if temp dist is greater than the threshold, which is 40 centimeters. So if it is big enough to be a way out, such as going out this way, or this, and this way at the end, then set direction count up 1. And if temp dist is greater than the dist, then the dist will be set to that, effectively making the dist the greatest distance found. And anytime it does it, it sets direction to I. This being, if it starts here, I is set to 1, that is going to be the greatest distance. So the greatest distance, the corridor path, the distance will be saved, and 1 will be saved. The direct 1, yes, 1 will be saved. So this is direction 1. As opposed to here, this is 1, this is 2, so now 2 will be saved. Then it will rotate, and it will do all this 4 times. Then escaped. If direction count is 3 or more, such as at the end, it will be 1, 2, 3. If it is 3 or more, it has escaped, so escape equals true. And then it will skip out drive, as seen here, and it will jump out of this while loop. Then, however, if it has not yet escaped, it will first aim down using that direction. It will aim to the correct corridor by turning 90 degrees until it's found it, until it's aiming down it, and then it will drive. It will drive the distance of the dist minus dist stop, which is the 7 centimeters, as we saw before. It will continue doing this until it has escaped. And the drive strain function is the same as before. Pre-loop, calculate distance, drive loop, which is read encoders, calculate the left speed, and whether or not they need to stop, and then set the speeds. And then whenever done, make sure that's stopped, and then pause. Rotate in place is the exact same thing, except the right motor is negative. Then the ultrasound function is the same as a previous lab, where for me, it is for how big the array will be. It will measure the distance where I cut it off so that if it goes off in the distance and doesn't get the signal back, it will say that it has timed out and set it as 0, which is why up here previously, if it is greater than the threshold or 0, because 0 means that it is much greater than the threshold since it expired. So then filter store. If the distance that it found is greater than the sensor max, then I-1. You don't store it, you try again. But if it is, it allows I to continue, and it sets the measurements array. Then simple bubble sort algorithm as provided. It will sort it in order of size, and then the median. Now that it's sorted in size, the median is just the middle value, which is 5 divided by half would be 2, so position 2. Then it returns that. And then simply count for distance, count for angle, as before. And that is the program.